Okay, so number 43 says, is this 6.4?
Yeah.
Okay, I'm on the wrong page. Okay. Here we go. 43, 6.5. I can't even get to the right page here. This is all on recording, too. This is good. It's important that happens. 48k to the what? K to the fourth minus 243. Okay, this is a great question. So first of all, you look at it. What's the first thing you notice when you look at this? It's to the fourth. Okay. What else do you notice? What other numbers are striking in this? They're big. Yeah, they are big. That is correct. They are big. So you want to try to break these down if you can. You want to try to break them down into something that you could recognize. Does anybody recognize 243? Okay, what's 3 to the first is 3. 3 squared is 9. 3 cubed is 27. 3 to the fourth is 3 squared times 3 squared. So what's that? 81. 3 to the fifth is 3 times 81, which is 243. Okay, so that might help us. It might not. But we have this. 3 to the what power? 3 to the... Okay, so we have 48k to the fourth minus 3 to the fifth. 48. How can we factor 48? What can we pull out of 48?
16.
Yeah, let's pull out 3 and 16. What's 16? 4 and 4, and each of these is a 2 and 2. So when you guys, you have to finish these questions. When you do a tree like this, what this means is, how many 2's do you see right there? There's this and this. So what does this turn into? 3 times 2 to the what? Fourth times k to the fourth minus 3 to the fifth. So is there one factor we just figured out we could pull out? What can we pull out? One of them, just one, right? So if we pull one of the 3's out, you're left with 2 to the fourth, k to the fourth, minus 3 to the what? 3 to the fourth. And you can glue that back together. You can say it as 2k to the what power? Fourth minus 3 to the fourth. Now, what? I put it back together. 2 to the fourth times k to the fourth is 2k to the fourth. I just put these two back together so we can get through the next step. So you look at this, and what's nice now, what are the powers in both cases? 4. So what do you actually have right there? That's the difference of fourth power, which is the same really as the difference of, it is the difference of squares, because this is, ready? 2k squared to the what power? Squared minus 3 squared to the what power? Squared. So what do you have? Difference of, you have the difference of squares. So what does that mean this is? 3 times 2k squared minus 3 squared times what? 2k quantity squared plus 3 what? 3 squared. Now the real question is, are we done?
No.
Let's just finish this and we'll go back. Are we done? Not quite. What do we see in the middle? What do you see? The difference of? So what does this turn into? 3 times 2k plus 3 times what? 2k minus 3, and what's still left over? 2k squared plus, let's say 9. Now are we done? This is a long one. This is a really long one. Yeah, actually, maybe it was one of the ones you did last night. I'm not quite sure. If you had like this, a to the 16th minus 1. A to the 16th. A to the 16th is what squared? A to the, no, a to the 8th squared, because you multiply powers of powers, right? So what do you see right there? Well, hey, 1 is 1 squared, right? Correct? So what do you see? I see difference of. So what does this factor into, Milo? A to the, yep, a to the 8th minus 1 times plus 1. You apply the formula. Hey, but are we done? No, what is a to the 8th? A to the 4th squared minus 1 squared. We have a to the 8th plus 1. So what does this factor into? Yeah, it's a pyramid of fun. What does it factor into, Alex? What's it factor into? This one right here. A to the, no, a to the 4th minus 1 times times 8. Wait, this one's just coming down. The a to the 8th is just along for the ride. Oh, are we done? What's that? That's the difference of, that's a squared minus 1 squared. A to the 4th plus 1 times a to the 8th plus 1. Oh, what is this one? What is this one, Nick? What does this one factor into? That's the difference of squares, the green right there. So what does that factor into?
That could be a squared.
Yep.
Times
A squared minus 1. Yep.
minus 1
Times
b squared
plus 1, and then you still have the rest of it, right? The difference, you have sum of squares right here, two of them. But are you done?
No.
Nope, not done. Now you have the blue one. So what does this become? A plus 1 times a minus 1 times a squared plus 1 times a to the 4th plus 1 times a to the 8th plus 1. What's really... No, you're done. These right here are all sum of squares, so you can't.
I meant on that one, we factored out the a, 2 of the 8 on that one.
We didn't we turned, just to recap, we turned this into these two, right? Then we turned that one into those two, and then we turned this one into these two, and then we turned this one into these two. We kept on making it bigger. Not half, but yeah, that's the pattern it comes out to be. Yeah, that's the pattern. But the point is, what we've just shown, this thing is a to the 16th minus 1. It's kind of cool. What's really interesting about it is, going from here to here, that seemed annoying, right? Do you agree it seemed a little annoying? You know what's worse? Let's say I gave you this and said, what does that equal? What happens if I gave you this? You would have to foil, right? And hopefully everything cancels, right? But what does that equal? A to the 16th minus 1. It's pretty cool. It's a cool question. No, it's not, but nice. Okay, so first, big numbers, and you see a cube, right? If you see a cube, one cube, you'd really like to see another cube, right? The point is 875, though, does that look like a cube? So you should factor these numbers. Let's factor them. What can you pull out of 875?
7.
Well, what's more clearly a factor than 7? 5 or 25, right? Let's try 25. I like 25. If you pull out 25, what are you left with? 4, 32, 35, I think. Well, how many? Here's how. This is what I think in my head when I do that. It's not as though I think of it and it just magically falls out. I break it down into pieces. 875 is equal to 800 and what? 75, right? How many 25s go into 800? Well, that's 100 times 8, right? How many go into 100? How many times is 25? What's 4 times 8? What's 32? How many times does 25 go into there? So that's how I got 35. Break it down into pieces. Okay, can you break down 25? Yeah, what is that? 5 and? And what's this? 5 and? 7. So what does this actually equal? This is 56k cubed minus what? 5 to the times. What's 56? Yeah, 7 times 8 times k cubed minus 5 cubed times 7. What can I factor out of both of those? Now if I factor this out, I end up with 8k cubed minus 5 cubed. What is 8? 2 cubed. So you end up with 7 times 2 cubed, k cubed minus 5 cubed. But 2 cubed and k cubed, you can glue them back together, right? 2 cubed times k cubed is the same as what?
2k.
Exactly, 2k cubed. Now what do we have? Difference of cubes. Yes, Mark, go ahead. Need it to go after cubes. You have k cubed. Your clue that you're going after cubes is that k cubed, and there's no other k to factor out. It's all by itself. So you better get some other cubes in there. So hey, look what we have. We have difference of cubes. Do you remember what that formula says? It says x cubed minus y cubed. What is it, Nick?
2k.
No, well, hold on. Equals. Just tell me what the formula is. It's x.
It's x squared.
No, it's something out front. It's x minus y times what?
X squared.
Yep. Plus xy
Plus y squared.
plus y squared, right. So if we apply that formula, what do we end up with?
You're talking about the second part.
Yeah, I'm talking, if I take this right there, it's going to be 2k minus what? 5 times 2k squared plus 5 times 2k, right? Plus,
Doesn't matter.
yeah, it doesn't matter which way. Exactly, yeah, exactly. Plus what? 5 squared, exactly. This right here, just clean it up a little bit. This is what I would like to see for the final answer. 2k minus 5 times 4k squared plus 10k plus 25. There you go. That would be a great final answer right there. So here, I want to ask you something. If two things multiply together to get 0, say A and B, what do you know at least one of them has to be? Zero factor property. If two numbers have a product of 0, then at least one of the numbers must be 0. Okay, so let's expand this to zero product property. How many things do you see multiplied together right here? There are two things. What's the first thing you see? There's one thing, purple thing, and then you have the green box. There are two things multiplied together to get 0. Well, if two things multiply to get 0, one or both have to be what?
0.
So you know that x plus 6 has to what? Or what has to be true?
2x.
Exactly. So what does x equal? X is equal to?
X plus
On this one, x is equal to what?
negative
-6. And on this one, you know 2x is equal to 3. So x is equal to?
Or they can both equal 0.
And we've just shown that can they both equal 0 at the same time? Really?
Wait, no.
No, we've just shown that it's either -6 or 3 over 2. Yes, but in this case, it's one or the other.
Yeah.
The point is you've just done something. This right here, you're going to do things like this for the rest of your math career. You're going to see a bunch of things multiplied together. You know that at least one of them has to be 0. So you break it down into smaller pieces. You break it down into smaller pieces. So how else could this be applied? So let's say I gave you this, another one. X squared plus 5x is equal to -6. Let's say I gave you that right there. First of all, to apply this zero factor property, what does the equation have to equal? 0. Step 1. Does it equal 0? No. So what do? Tell me what I do to make it equal 0. Add 6 to both sides. Do I change anything about the overall validity or truthiness of this equation by adding 6 to both sides? It stays the same. So what do we end up with? X squared plus 6 equals. Do we have things multiplied together there? Yeah, but there's also those plus signs. We want to turn it into something times something equals 0. Or something times something times something equals 0. How do we do that? What do? Factor! What does that factor into on the left? X plus 2 times plus 3. So what does that equal? 0. Oh! So what does x have to be? -2, or x is equal to? -3. Oh, look at this.
It's always just the new.
What makes, so you have x plus 2 equals 0. So I just didn't do it out. Right. So what's the last thing you could do? You get an answer, you could also check it, is what it could be prime, yeah. But if it's prime, then we're kind of stuck. Let's check it. X squared plus 5x when x is equal to -2. Kids, important, pay attention, please. Thank you. Harry, put your bag on the ground, please. You have x squared. You want to know what x squared plus 5 is when x is equal to -2? What do you get? -2 squared plus 5 times -2? 4 minus 10. What's 4 minus 10? Is that what we want it to be? Yes. But what do we want also to check? X squared plus 5x when x is equal to -3. So you get -3 squared plus 5 times -3. So you get 9 minus 15 is? Is that what we want?
Yeah.
So they both check and you are happy. They both check and you are happy. So once again, what we're about to do is entirely related to this. Two things or more. So could you have A, B, and C multiplied together? Sure. One of them or two or all of them have to equal 0. The only way to get 0 when you multiply things together is one or more of the elements has to equal an equation that can be written in the form of ax squared plus bx plus c equals 0, where a, b, and c are real numbers. You see real right there. And a doesn't equal 0. What happens if a is equal to 0? What goes away? The x squared goes away, right? And it's not a quadratic anymore, so a isn't 0. Can b be 0? Can c be 0? This is called, everybody, quadratic equation. This is also called standard form. You know how lines can be written in slope-intercept or point-slope or standard form? There's different forms for quadratics. We're going to call this quadratic. We're going to call this standard form for quadratics. This is standard form for quadratics. All we've done at this point is rearrange. That's it. But we have two things multiplied together. What's the first thing, Milo?
2x.
Yes. And what's the second thing, Alex? What's the second thing? Yes, exactly. So what do we know? 2x minus 1 has to equal, or what? Has to equal. So what do you get? 2x is equal to 1. So x is equal to 1/2. Or x is equal to -2. So these right here would be your answers. You have two answers right there. And the way you could write that, remember set notation, everybody? Remember this? This would be the answer right there. Yay! Yay! Okay. How about you try, kids? Try this one right here. Try that one. Try that one by yourself. Tell me a little bit about this. What should I do first? Is it in standard form?
Yes.
Everything's combined that can be combined. What should you do first? Factor. Always look for greatest common factors. What can you factor out of this? Yeah, you could do 4x times what? X minus 5. Do you have two things multiplied together? Yeah, so either 4x equals 0 or what? Equals 0. So x is equal to, which is a possible answer, or x is equal to 5. Best way to write this solution set, 0, 5. Boom. Nice. Do number 1 first, and we'll check in on number 1 before you do number 2 or 3. Just do number 1, and then keep going, but it's okay if you don't finish. On the first one, what should I do first on this one? 3. Turns out 3 times x squared minus what? What? 36? Oh, what do you see right there, Obs? What is that? Yeah, so you get x plus 6 times. So what are the two answers? X equals 6 or? Which you could write as -6, 6. Nice.
Do the 3 and the end it all.
The 3 doesn't, you can't be 0.
Yeah.
3 can never be 0, so you ignore it. Yep. Okay, so what were those steps? Remember these steps right here? It says first, write in standard form. So on this one, is this in standard form, number 2? Is it in standard form? No. So what do you need to do first? You need to FOIL and put it in standard form. Then you can move forward. So, do it. So on this next one, you have to clean it up. So it's 2x squared plus 2x plus x plus 1 is equal to 2x. Well, 2 minus 2x plus 6. Is that in standard form yet?
No.
No. It's closer, right? 3x plus 1 is equal to 2. So what does that become? 8 minus 2x. And then you add 2x, so you get 2x squared plus what? 5x minus what? Equals?
0.
How many people got that? 2x squared plus 5x minus 7 is equal to 0. Who got that? Raise your hand. Nice. So again, you're going to factor this into 2x and what? Equals. You need two numbers that multiply together to get what? -7. -7. And what's the only way to do that? Yeah, how about this? -1 and 7. What do you have to do, though? Are you sure about this? We're not sure, so what do we need to do? Test it. Let's try it. 2x squared minus 2x plus 7x minus 7 equals 0. Is that the same thing? Is that what we want?
No. Oh, yeah.
Yeah, it is. It is. So, what do we? If that's the proper factoring, we now know 2x plus 7 must equal what?
0.
Or what? X minus 1 equals. Oh, look. So 2x is equal to -7. So x is equal to -7 over, or x is equal to 1. So how do you write this answer? -7 over 2, 1. I know.